Good day, family. Thank you so much for joining in on this lesson. If you're new to this channel, please consider subscribing and liking the video. In today's lesson, we're going to focus on two important aspects concerning solving linear equations. That is expressions versus equations. And examples, we're going to look at lower order to higher order examples. So let's look at expressions versus equations. So I'm going to start off with an expression. An expression is always made up of terms. These here are referred to as terms. So this expression is made up of two terms. It's made up of two terms and one operator. So the important thing to know about an expression is made up of terms and operators. And the whole thing together is called an expression. Now moving on to an equation. An equation is made up of terms, operators, like this here, and an equal sign. So already we can see the first difference between an expression and an equation. The first difference is an equation has an operator and an equal sign, whereas an expression only has an operator or operators. And the second important thing about an equation is that it has a left-hand side and a right-hand side. So those are the two important aspects or the differences between expressions and equations. Right, so let's look at the examples, starting from lower order to higher order. So if you look at the first equation, because it is an example, if you look at the left-hand side, we can write this as 6x. Then what we do with the 3 is we bring it inside the brackets. So you bring this 3 inside. 3 times x is minus 3x, or minus 3 times x is minus 3x, and minus 3 times 2, minus 3 times 2 is minus 6, is equals to 3 plus 6x. And the next step when solving equations is always to group terms, group like terms. So what you'd want to do here is put the variables on the left hand side, all the terms containing variables on the left side, and all the terms containing constants on the right hand side. So let's just identify all the variables having, all the terms having variables. This is a term, this is a term, and this is a term. So we can put all of those on the left hand side, and all the constants, we can put those on the right hand side. So you should get 6x minus 3x minus 6x is equals to 3 plus 6. So already by inspection, we can see that 6x minus 6x cancel each other out. So we are left with minus 3x is equals to 9. So what we can do here is we can divide both sides by negative 3 to remove or to isolate x. So divide both sides by negative 3. It implies that x should be equals to negative 3. So let's have a look at the second one. I think the most important part of solving equations is always to try and eliminate the brackets. Always try and eliminate the brackets when solving for x. This is actually a very interesting question, because if you have a look at this negative, what you might not notice is that it's actually negative 1. So we can write this as x, and then we can eliminate these brackets by bringing in the negative 1. So it's negative 1 times x is negative 1x, negative or negative x, and negative 1 times negative 2, bring it inside, it's positive 2. It's positive 2. Then we have on this side, when we bring it in, negative 2 times x is negative 2x, negative 2x, and then negative 2 times negative 3 is positive 6 is equals to 0. So now we can collect like terms, group like terms. So by inspection, these are like terms. This is a like term, this is a like term, this is a like term, and the constants are like terms. So I think, like we did in the first example, have all the variables, all the terms containing variables on the left-hand side and all the constants on the right-hand side. So there I've sorted that out, and then we can see by inspection that x and x cancel out. So on the left-hand side, you're left with minus 2x, and then on the right-hand side, you have negative 8. So what you do now is you divide throughout with negative 2 to isolate the x. So you divide both sides by negative 2, negative 2. This and this cancels out. So then it implies that x should be equals to negative 8. And then finally, when dealing with equations that have fractions, it's so crucial that we find the lowest common multiple. And to find the lowest common multiple of the terms that contain fractions. So one needs to find the lowest common multiple of those two denominators. And what I normally do is I write down the multiples of 3. I write down the multiples of 3. So it's 3, it's 3, 6, 3, 6, 9, 12, 15. And I write down the multiples of 4, 4, 8, 12, 16, 20. So by inspection, we can see the lowest common multiple for both terms is 12. The lowest common multiple for both terms is 12. So what you do with that is you multiply the left-hand side and the right-hand side by the LCM. So you multiply by the LCM, which is 12. So it would be 12 times 3 times 1 over 3 leaves you 4 with 4. Or let me rather just write it for you. So after multiplying throughout with 12, this is what you get. And then obviously we can cancel out. 3 goes into 12 4 times. And 12 times 2 is 24. And 4 goes into 12 3 times. And 12 times 15 is 180. 12 times 15 is 180. So then we can write this as 4 times 5 is 20x minus 24 is equals to 3x plus 180. So we can group like terms with the constants being one side and the terms containing variables one side. So here we have 20x minus 3x is equals to 180 plus 24. So therefore 17x should give you 204. And when we divide both sides, when we divide the left-hand side and the right-hand side by 17, divide both sides by 17, divide both sides by 17, we should get the following. 17 and 17 cancel out. So this implies that x should be equals to 12.